Europe is rebuilding a capability it once treated as a legacy: artillery delivered in volume, sustained over time. The machines are only one part of the story. Doctrine and industry decide what those machines can actually do. This is Troop Talk. Let's begin. A gun line wakes before dawn. Diesel idles in the cold. Helmet lamps sketch pale cones across mud and steel as a wheeled howitzer rolls off a paved road and settles onto a scraped hardstand. A hydraulic whine lowers the rear spade. The barrel slews. A 155mm round slides into the chamber, followed by modular charges stacked like bricks of compressed chemistry. The breech shuts. The crew waits for a number to become a target. The fire mission arrives as coordinates, not as drama. The chassis settles, the barrel recoils, and the pressure wave hits the chest before the sound fully arrives. A timer starts immediately, because the most important skill in modern artillery is leaving before a drone or radar can turn a firing point into a map reference. Across Europe, that rhythm has returned. Arrive, fire, move. What has changed is the strategic context. Since 2022, wars on Europe's periphery have exposed a blunt truth about modern armies. Precision matters, but mass still decides. Not mass of soldiers alone. Mass of steel, propellant, spare parts, and trained crews able to repeat a firing cycle thousands of times. Policy now follows that logic. On November 10, 2025, the European Commission highlighted progress under its Act in support of ammunition production at Kemring Nobel's facilities in Norway, backing projects intended to expand explosives and propellant output and to relieve bottlenecks that have constrained European supply chains. The signal was industrial. Barrels matter, but chemical capacity sets the ceiling. On November 19, 2025, KNDS staged a rollout in Munich of Leopard 2A8 tanks and PZH-2000 howitzers for Germany and Norway, framing it as replacement for equipment transferred to Ukraine and as evidence of a procurement model pulling several countries towards common configurations. The point was not ceremony. It was schedule and throughput. Deliveries for Germany were set to start in 2026. On December 5, 2025, Reuters reported that the Czech defense group CSG signed a framework agreement with Slovakia aimed at supplying ammunition to EU states through a safe financed structure, a contract measured in years rather than crises. And on November 30, 2025, European coverage of stalled talks over UK participation in SAFE underlined that rearmament is also an argument over who gets to build and who gets paid. Against that backdrop, Europe's artillery race is often reduced to a contest between iconic systems: France's Caesar, Germany's PZH-2000, Sweden's Archer, Poland's Krab, and a new generation of highly automated gun modules such as the RCH-155. Yet these machines were not built to win a single ranking. Each is a different answer to the same question: how to deliver lethal fire while surviving in a battle space dense with sensors. Caesar begins with a French instinct: strategic mobility and rapid deployment. Its wheeled chassis can travel at highway speeds and reposition over long distances without transporters, reducing the logistical drag that slows heavy tracked fleets. In practical terms, a battery can shift along a front, redeploy between regions, or operate on a dispersed road network with less strain on bridges and fuel. The trade-off is protection. A wheeled howitzer does not pretend to be a tank. Survivability is built on time and discipline, short halts, quick firing, and immediate displacement. The gun itself is a NATO standard 155mm 52 caliber barrel, compatible with ammunition families that push standard shells beyond 30 kilometers, and extended range rounds into the 40-kilometer class and beyond, depending on projectile and charge. Those ranges are not trophies. They change where resupply points can sit and how far a battery can remain from the forward edge while still shaping the fight. Cesar's automation sits in the middle ground. It compresses timelines and reduces crew workload, but it still depends on trained hands to keep a high tempo. The consequence is a system that rewards armies with strong gunnery culture and robust training pipelines. It is also a system that tends to scale well financially because wheeled vehicles are cheaper to move and generally easier to maintain than heavy tracked systems, especially when deployed over long road marches. Germany's PZH-2000 is built around a different assumption, that the gun may have to fight for its life in a duel, under observation by drones and counter-battery radars. It answers with mass, protection, and sustained capacity. At roughly the weight class of a main battle tank, it crosses broken ground with the confidence of tracks and the appetite of a heavy engine, following armored formations where wheeled systems can be limited by mud, craters, or destroyed roadbeds. Its internal logic is firepower maintained over minutes, not seconds. A large onboard magazine, commonly described at around 60 rounds, allows high-volume fire before immediate resupply becomes decisive. In counter-battery conditions, that matters. The gun that can deliver a concentrated burst, displace, and still retain enough ammunition for a second mission changes the geometry of risk across a front. The cost is not only acquisition, it is dependency. Heavy tracked systems demand recovery vehicles, specialized maintenance, and deep stocks of spares. They also punish training schedules because the platform is complex, a turret full of electronics, hydraulics, and precision mechanisms that must work in heat, dust, ice, and vibration. When PZH-2000 is called advanced, the implication is not only capability, it is the industrial ecosystem required to keep it reliable. Sweden's Archer leans hard into automation and speed, shaped by a national problem set of long distances and limited manpower. A small crew, often 3, can execute a mission with minimal exposure outside the cab. Ammunition handling is mechanized, and onboard storage, typically about 20 to 21 rounds, supports rapid salvos without immediate resupply. That storage figure becomes a tactical constraint. Archer can strike quickly, but it cannot sustain long fire missions without a logistics rhythm behind it. The design assumes the gun will shoot, relocate, and reload under cover or further back. In practice, it favors a dispersed artillery posture, more movement, more deception, fewer minutes spent where an enemy sensor might linger. In parallel, Poland's Krab reflects another European logic, artillery built for scale. It is a tracked 155mm 52 caliber self-propelled howitzer intended for battalion-level employment, where volume of fire and the ability to absorb losses matter. The tracked chassis gives cross-country mobility, and the turreted gun provides the protection and stability expected from an armored artillery vehicle. Krab's central trade-off is institutional. Scale demands industry. Buying guns is the visible part, sustaining them is the quiet part. Barrels wear, tracks break, fire control components fail. A state that wants massed artillery must also build a pipeline of trained gunners, maintainers, depots, and steady ammunition delivery, or the fleet becomes an inventory statistic rather than a battlefield instrument. The newest European designs push the logic further toward reduced crew exposure and shortened firing cycles. The RCH-15-5 concept, built around a 155mm 52 caliber gun module mounted on an 8x8 vehicle, reflects a battle space crowded with sensors. Automation is meant to shrink the time a crew is visible, simplify operation, and allow smaller teams, in some cases aiming toward a 2-person crew. The trade-off is complexity and cost. When a turret becomes a computer on wheels, survivability depends on electronic robustness as much as steel. Maintenance becomes an information problem, diagnostics, software integration, component supply for actuators and sensors. And while an 8x8 offers high road mobility and easier strategic transport than tracked guns, it still depends on intact road networks and predictable fuel supply.
These differences are often discussed as engineering choices. In reality, they are national statements. A wheeled gun signals confidence in movement and infrastructure, and the willingness to accept thinner armor in exchange for tempo. A heavy-tracked gun signals a willingness to carry logistic weight in exchange for protection and sustained fire. High automation signals a manpower strategy, not only a technical one. The question then is not which platform is best. It is what kind of war a state's procurement system is preparing for, and what it assumes will be scarce first: time, crews, roads, bridges, or ammunition. On paper, most European systems now converge on a NATO standard caliber and a similar ballistic class. A 155mm 52 caliber barrel has become a baseline because it offers range and interoperability. In practice, interoperability can be a mirage. A 155mm shell is not a single object. Propellant charges vary, fuses vary, packaging standards vary. Quality control determines whether a promised range is achieved safely, repeatedly, without destroying barrels or scattering dispersions that make fire less decisive. That is why the structural layer matters. Europe's artillery story is increasingly a story about chemistry and machining. Propellants require nitrocellulose. Explosives require stable precursor supply and secure handling. Shell bodies require forging capacity and precision machining. Fuses require electronics and test equipment. Every step has bottlenecks, many outside the classic defense primes, in industries that spent decades optimized for peacetime volumes. This is the part of the race that rarely appears in brochures. A self-propelled howitzer can arrive on schedule and still be effectively absent from a war if its ammunition allocation is thin. The rate of fire that matters in sustained combat is not rounds per minute. It is rounds per month that can be replenished, stored, transported, and fused without failure. There is also a tactical chain that must be built around the gun. Counter-battery radars, drones that spot muzzle flashes, secure radios that survive jamming, and fire control networks that turn sensor data into aim points in under a minute. A modern howitzer without that chain is reduced to area fire. With that chain, it becomes a precision instrument that can still deliver mass. Europe has tried to respond by turning procurement into long-term demand. The SAFE instrument is one attempt to make contracts predictable enough that factories can justify new lines. ASAP is another, focused on the dull but decisive expansions: propellant mixers, explosives casting, test ranges, and packaging facilities. Both are acknowledgments that artillery is an industrial discipline.
Recent developments show how quickly these choices are hardening. The Munich rollout on November 19, 2025 was presented as a shared European procurement pathway, with multiple countries converging on common platforms. That promises economies of scale, but it also ties nations to shared timelines and shared supply chains. The stalled SAFE discussions reported on November 30, 2025 showed the other side: industrial policy as boundary making, even when capability needs are urgent. The Slovakia CSG Framework Agreement reported on December 5, 2025 made the point through economics rather than diplomacy. Multi-year contracts de-risk investment and accelerate expansion. They also lock in suppliers, shaping which firms become the backbone of European firepower and which become peripheral. In the near term, 12 to 24 months, the countries that gain the most will be those that treat artillery as an ecosystem. Guns will enter service, but so will new production lines, new depots, and new standards for common ammunition handling. Training will matter as much as delivery schedules, because the fastest procurement is irrelevant without crews that can exploit automation, manage dispersion, and survive counter-battery pressure. Uncertainty remains. Ammunition demand is sensitive to battlefield intensity and political decisions.
Industrial ramp-ups can be undermined by shortages in chemicals, skilled labor, and machine tools. And the most automated platforms depend on electronic supply chains competing with civilian demand. Europe is trying to solve these problems with money and coordination, but coordination is a capability of its own. Back on the gun line, the crew does not debate doctrine. The vehicle is already moving. The spade rises. Dust settles into tire treads. Somewhere a radar searches for a point of origin that no longer exists. The barrels will keep firing. The question is whether Europe can keep the factories, the depots, and the training lines moving at the same pace for years ahead.